Hello, in this video I'm going to go over the S1 Edexcel question for June 2016 of the questions in this exam. I think, remembering students walking out of the exam last year, this was the one that caused the most grief, I think. It's probably a bit unusual, probably put people off. If ever that happens in the exam, try and think things through. Don't panic. I think that was the reaction of many students looking at this. Panic. Not seeing anything like that. What kind of Venn diagram is that? This kind of thing. So let's just work through it. First bit says write down the probability that the customer books breakfast but not book a room. Well, if you look at it, breakfast is entirely inside, entirely contained within the booking room set. So it's impossible. If they book breakfast, then they must have booked a room as well. So it's impossible that they haven't got a room if they book breakfast. So the answer to that is 0. Because if they have had breakfast, then they must have had a room. So zero possibility there. Then it says given that B, D are independent, find the value of T. Well, let's just. A condition for independence is that the probability of A and B happening, or not A, well, it's just writing the same symbols, the probability of B and D happening is equal to the probability of B times by the probability of D, if independent. Okay, so that's what we're that's what we're going to use. Well, PB intersection D, that's both. It's both of them happening. That must be, if we look at the set D, that's this one, and the set B, that's this one. Probability of both of them happening is that 0.27 in the middle there. The probability of B happening is those two added together, which is 0.6. 0.33 plus 0.27 is 0.6, times by the probability of D happening. That's the whole lot of this, and this is our T, which we're being asked to find. So that's times by, let's just bracket it, 0.27 plus 0.15 plus T. Okay, so we can easily work that out. We have let's divide by 0.6, so that's 0.27 divided by 0.6, which comes to 0.45, equals to these two added together, which is 0.42 plus T. So T is equal to 0.03. Right, so that's part B done, nice easy, well, 4 marks. So I don't think, as I say, that should have been okay. I don't think that should have posed a problem if we just think the things through. Okay, part C, hence find the value of U. Well, that's now kind of a bit of a bonus mark for 2 marks. They all must add up to 1. So we've got U plus 0.33 plus 0.27 plus 0.15 plus T, which is we now know is 0.03, equals to 1. So that gives us that U equals 0.22. Okay, right, and then it says, so that's that. Then it says find the value of this is, I suppose, getting a little bit more problematic, conditional probability. I'm not going to use a kind of general rule for prediction, well, not directly anyway, I'm not going to refer to it. PA conditional on B is equal to PA intersection B over PB. I'm not going to use that. It is possible to use it that, but I find it a little bit unnecessarily complicated. I'm going to kind of use what I think sometimes the textbook talks about a restricted sample space, and do it directly from the Venn diagram. And work those out and just think it through that way a little bit, I suppose, if you like, by common sense, if you like. So, looking at the Venn diagram, R intersection B, well, first of all, that's the same as R probability D is conditional on B, because R intersection B is exactly the same as B. But anyway, let's just mark out where that region is, or get rid of everything that doesn't apply to, maybe. So that's all of that. So I have, that's my restricted sample space. And we now know that B has happened, or R intersection B has happened, which is the same thing. And we now are being asked for, given that we know that B has happened, or R intersection B has happened, what is the probability of D happening? Now, just I've scrubbed it out, but D is this set here. Okay, so the whole amount here, let's write down the thing, P, D conditional on R intersection B. The whole amount here is 0.6. And the amount we're looking for, because we know that that's definitely happened, so we're looking at 0.6 of the thing which we know has now happened. And now the probability that given that's happened, that D actually happens, is 0.27. So that's the probability within that is 0.27. And so that gives us the answer, which is 0.45. Apologies, I seem to have written an extra 2 there. I don't know if I did that deliberately or whatever, but it's 0.22 for the previous question. So sorry about that. Anyway, it's 0.45. Another way of looking at that, I suppose, is to say that, as I've already said, PDR intersection B is equal to the same as PD conditional on on B, because that means the same thing. And because we've already shown that D and B are independent, that's the same as the probability of D. And if we get rid of this now, we can see the probability of those three added all together is 0.45. So that's another way of looking at the same thing. Didn't occur to me at the time. In some ways it's simpler, but didn't occur to me, but it's an alternative. Okay, let's look at the second part. For the second part, we're looking at this as our kind of restricted space, R intersection B but dash. That means the set we're looking at is that R happens and B doesn't happen. So R happens, so it's got to be within R, so we can scrub out everything that's not in R, but also that B does not happen. So we're scrubbing out the whole of D there. So that's the set we're looking at, this kind of funny little kind of bit with the bit with, well, I don't know what we describe it, but the outer bit of this circle, kind of bit in between. Basically this bit here is our set that we're considering. So let's not forget we've worked, so let's not forget we've worked out U in this, which is 0.22. So now we're being asked for the probability that D happens given that R intersection B happens, intersection B dash doesn't happen. So in actual context, we're being asked for the probability that they have dinner given that they've ordered a room and not had breakfast. Okay, so that's basically what we're being asked for in kind of in context. Well, again, the whole of this set is these two added together. That's 0.37. Okay, now that's not the whole of this set, and then we've got the probability that D happens within that. Again, remember D, I've scrubbed it out, is this bit here, in this bit, so it's the 0.15. So that's 15 over 37. Okay, so that's that question done. Right, okay, so I think again that's probably the best approach. Hopefully you found that useful. There is one more bit to do. it does relate to what we've just done. So I'm going to move that. And it does relate to our two answers here. It does relate to these two answers. Okay? Because it says a coach of 77 customers arrived at the hotel. Of these 77 customers, and this is the key, the 77 is a bit of a red herring, if you like. It's 40 have booked a room and a breakfast, and 37 have booked a room without breakfast. Those are exactly described by these probabilities here. Estimate how many of them, of these 77, will book dinner. So, for the ones that have booked a room and breakfast, which is this, 0.45 of those 40 will have booked dinner as an estimate. So that's 40 times 0. Let's try and write it in a proper estimate. Is 40 times by 0.45. Okay, and then for the 37 that have booked a room without breakfast, okay, the 37, then this one is the one we're going on. So that's plus 37 times 15 over 37. So, because 15 over 37 on average in the long run, of people who book a room but don't have breakfast will have dinner. And we got 37 of them, so that's an estimate of how many it will be. It doesn't have to be, of course, because randomly it probably isn't this exactly, but it's just an estimate of what it would be. So all that added together comes to 33. Okay, so hopefully you found this video useful. I am rushing these things out because the exam's in a few days' time. If there are any mistakes, please shout out so that no one else follows it. I'm not checking this, I'm going to upload it straight away. Thank you. Bye.